Now that we have our disc all done, we have to make the two charge collectors that go on both sides and the disc run between them. And they're basically just combs to pull the electrons off of those sections that we made. Well, what this is a pipe hanger. The pipe sits here and you just tap it into a joist, hang the pipe. It actually took me a long time to find ones that were copper coated. All the other ones I saw were just plain steel, but I finally found the set. I can't remember if I got these at Lowe's or Home Depot. One of them had them kind of tucked away in the back. So I grabbed those, and now we have to make the combs, which are going to end up looking... Butterfingers today. End up looking like this. So we have to wrap wire around here and cut it to make all these little sections here, and then space them out evenly and solder them in place. So there are 12 on this here. There are 12 individual combs. So alright, so now we have to wrap and start our combs. This is just regular hookup wire. You can get it Radio Shack or any other electronic supply. This is, I believe it's either 22 or 24 gauge. You know, it comes in a roll like this. I just stripped the insulation off. As long as it's solid core wire, you're all set. So we're going to do 12 wraps. I'm going to hook one side, and I'm going to go where the bend is so it's nice and strong, so as I wrap it, it doesn't squeeze itself down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now we'll just take those and cut the bottoms right in half there. Now we have 12 individual pieces. I'm going to straighten them out, line them up. I'm gonna keep these on for now, but if you can see right where it makes that bend right there, that's where I'm going to end up cutting these off. So from here down, I'm going to evenly space these 12, and then we'll get to soldering them in place. Alright, we got them all evenly spaced, and here's what I'm going to use to solder them, which is the little micro torch, which works really well. You can also use a regular soldering iron. This is just a little bit easier because you have such a big piece of metal to heat up. And I'm going to be using regular electronics rosin cord solder. So I don't know if you can see the flame really well. Put your heat on the bottom. And then touch your solder to the top. Alright, I'm going to get my Dremel and I'm going to cut the two ends off there. That's not really hot anymore. So I'll be right back. Alright, cut those off, and these are just some little threaded brass balls that are for lamps and stuff like that. They'll fit right on the end here. Just to dress it up a little bit. And go ahead and solder those in. Nope, seem to be out of butane. Gotta refill it. Okay, now that we have our collectors made, we need to make our Leyden jars that these are going to hook into. Now I'm going to deviate from the way the plans have the generator set up. The way they have it is they have the Leyden jar and the collectors as one piece, pretty much in this configuration here. I don't want to do that. I want these Leyden jars separate from that. So we're going to have the collector over here on a rod, and then we'll have a wire coming from here into the Leyden jar. And the reason why I want to do it that way is because I want to be able to change these out with different size Leyden jars and different materials and see what works best. The first way we're going to do it for now is just how they have it in the plans, which is using a piece of clear tube, and this is the plastic tubing from fluorescent light protectors. They slide over the fluorescent tube to prevent them from breaking, or if they do break, it'll contain all the shards in the tube. I've already cut them into 7-inch lengths or 7.5-inch lengths, and I've already made one of them. And all this is tin foil. Now, a Leyden jar, if you don't know, is the earliest form of capacitors, and depending on the surface area, that determines the actual strength of the charge. Obviously, more surface area, the higher the charge. They are dangerous if you get them too big. Even the small ones, if hit the right way, can hurt a lot or even kill. Leyden jars actually did kill its inventor, so they are also known as death jars. So it's just something you want to be very careful with around whenever you're using one, and whenever you use the generator, make sure you short them out to make sure that there's no residual charge, because they can get charged just by sitting around. They'll pick up a static charge, even off of a TV set. It's actually how I tested these. Basically, this is very, very simple. All you have is a foil on the inside, an insulator, which is your plastic tube, and then another foil conductor on the outside. And that is basically how your charge is held, is in those plates. The actual theory behind it, I'm not sure, so I'm not even going to attempt to explain exactly how, but I just know it holds a charge. So we're going to make them with the aluminum foil in these tubes, and maybe later on I'll get into, after we get some testing with the actual machine, make a bigger one, make some different materials. Actually, the first idea I had was using the brass shim stock that I have, just because it's very springy and it's thick enough that you won't get any ripples in it. So we'll also try that too as a Leyden jar and see if it works any better than this. So anyway, I have the tube cut out at 7.5 inches, and I already have my squares of aluminum foil cut out, one for the inside, one for the outside. So we'll do the inside one first, and I've already wiped the inside of this out. Take the foil, we'll roll it up, and get it in place. Take a piece of paper, cut thinner than the actual foil, and you can roll that up, put it inside the foil tube, and now basically what you're doing is you're using that paper as a spring to force that foil out to the sides. We'll set it up an inch from one edge, right about there, and make sure that your edges here are straight. You're gonna get some. The foil that I have actually isn't that great in terms of not being wrinkly. I mean, when it was wrapped around the tube, there are some inherent wrinkles in the foil itself, but you want to try to keep it as smooth as humanly possible. So push the paper down to one end, so I have it right to the edge, but I have enough to be able to stick a piece of tape in there. Good old piece of Scotch tape, a pair of tweezers, and all I'm going to do is I'm going to lay a piece of tape in right over the seam of the foil, right to this tube to hold it. So we got one there, and on the other side. Now we can pull out our paper, and then put another piece 180 degrees from that one, and then same thing on the bottom here. Okay, so now we got that piece inside. As you can see, it's touching all the way around, or as good as it's ever going to be of touching the entire surface. You want to try to minimize air gaps. Slight small one right here, but that's not too bad at all. It's touching all the way around the other side. Now the outside one is obviously much easier. I'm just gonna trim this back a little bit. Right like that. Alright. So that's pretty much where we want it. So let's put a tiny bit of tape right here, just to hold that in place so I can pull it really tight. And like I said, you want to minimize wrinkles as much as possible. No matter what you do, you're going to get some in there, but and there's your Leyden jar, pretty much. That's all there is to it. The hardest part, like I said, is just wrapping the foil around, making sure you can kind of get it as smooth as possible. Now, I got some wrinkles in here, which will affect the performance of it, but it shouldn't be enough to make the machine not work. And then, like I said, I want to be able to switch these out and try, you know, some shim stock, something along these lines. As this is a little bit thicker. This is only about 10-4 is about a half a thousand thick, roughly. Maybe a little bit bigger. And this shim stock, obviously, the one I have, I made this one with, is actually 2000s. So it's a lot thicker to prevent wrinkles. So we'll see performance-wise if which one works better. I'm assuming this one is going to work better. And we'll also make a bigger one out of some PVC. Now, as far as I know, and from what I've been reading, is actually the thinner the insulator between these, the better. So as far as the thick PVC goes, I don't know if it'll work better or not. And but we'll see eventually. So let's get to actually doing the setting up the base and getting all our components pretty much together. Okay, we have both of our discs all set up. We just haven't enlarged the hole in the middle yet, but we'll get to that. We have both of our collector combs all made up, and we have both of our Leyden jars made up. Now, if you follow that link that I gave you, there is a large drawing of his setup of his base. Mine's going to be a little bit different. The way this is going to work is this is a piece of 7-inch by 24-inch piece of oak, and I transferred his dimensions onto one side of it. Now, my collector combs, unlike in the plans, which the collector combs are hooked into the Leyden jars directly, kind of in this configuration here, my Leyden jars are going to be separate. So these are going to sit out here, roughly, and the combs are going to sit somewhere in this vicinity on their own supports. And coming off of these collectors will be a wire hooked into the Leyden jars. The reason why I want to do it that way is because I want to be able to switch these Leyden jars out with different materials and different sizes and just kind of experiment a little bit and see what goes on. So I went ahead and laid everything out here, the measurements. I know you really can't see it real well, but everything's laid out according to his plans. So what I'm going to do is I'm going to drill the holes to be able to mount our uprights, which our uprights are 2 spindles from, this is the garbage piece, but 2 spindles for railings cut to length. So I cut off the ends of these to end up with this here. I clamped them together so that way there when I drill them I can get the holes in line with each other. So off of those uprights are going to be our pulleys on the bottom that we're going to turn to power the unit, which are these, which are 5-inch clothesline pulleys. I just cut the bracket that holds it off, and I was going to use these for the drive pulley on the discs themselves, which this is a roller from like screen doors that sit on the bottom of screen doors that rides in the track. The only problem is he does specify a specific belt from McMaster car, but I wanted to source it low. It was like 15-16 bucks for a quantity of 8, and I only needed 2, so I was able to source a similar belt from around here. This is actually a giant O-ring is all this is, but because of that, you can see this is a 1/4-inch O-ring, and this is about an 1/8-inch slot. It doesn't quite fit in that. So, and also in the plans he uses a rollerblade wheel that he cuts a groove in. A rollerblade wheel is about 2.5 inches or so. So this is a lot smaller, and it'll be able to go up with the pulley, but you'll have a lot of inertia and everything on this one tiny pulley, and I want it to be easy to crank and start. Not that it should be tough even with something this small, but I'm gonna end up making my own pulley, and I wanted to originally make it out of Delrin. The only problem is I can get Delrin around here, but for the size I need, it's actually really expensive and kind of cost prohibitive. It actually will cost more than everything else I put into this. So I found an alternative, and all it is, I gotta go actually pick up another one of these. This is the actual wheel for a caster. So I'm gonna get 2 matching ones. This is just happened to be one I had lying around just to try out. I'm gonna pop the bracket off of it, chuck it in the lathe, and we'll be able to cut it down the width, and we'll be able to make a tool for this 1/4" diameter here, so it'll fit perfectly in it, and that's what's going to go on the disc. So, but in the meantime, I want to be able to figure out how high on the uprights this is going to be. So we'll get everything laid out. We're going to get the uprights in, and we're going to get the axles in and get our height measurement for our actual pulley, and everything set up for that. Our axle is going to be those reflective stakes, those fiberglass reflective stakes that you use in the end of your driveway for plowing, to mark driveways and stuff. That's what our axle is going to be. You can use wood, a wood dowel, something non-conductive. The only problem with wood is you're going to be turning it through a wood hole, so it's going to bind a little bit. This is nice and smooth, and you won't need any kind of bushing or anything between this in the wood itself. I might just stick a if I can find like a nylon bushing or something that's 5/16, I might just slide it in the hole just to give it something. But our axle is going to be made out of this, both for the part we're going to crank, and then also what the discs themselves are going to spin on. So I have this marked out right now, and I'm going to go drill this hole in the drill press straight through, and I'm going to drill these holes here for screws, and then this hole and this hole. I'm going to wait until we get the disc in and see if that's actually where everything lines up. So let me just go drill these real quick. I'm not going to film it because you've seen people drill holes before, and I'll get right back. I just wanted to show you drilling the acrylic discs. You got to be very careful with them because they can be very grabby and very easy to crack. And if you see me crack this, you're going to see it go hurling across the room. I can guarantee you that. But we want to slow our drill press down to its slowest speed here. Nice and tight. Barely putting any pressure on there. I can feel we're about ready to break through. I'm going to put even less pressure on there now. We're pretty nice and snug on there. I like that. Alright, let's go mount these up to the base. Alright, so this is pretty much the basics of the machine. We have our pulleys down here. It'll probably be mounted somewhere around this area here. We'll have our belt that'll go up to our pulley that we're going to make, and our two combs. Those holes actually, where I had them marked out, actually ended up pretty much perfectly. I'm going to get a square pole or a round piece of oak or something and come up, and then we'll be able to align this on center about here, and I'll connect a rod. I have some 1/2-inch brass over there. What I'll probably end up doing is making a groove in that to be able to accept the radius of this and solder it in place, and then have that anchored to the base with an insulator, or anchored to a piece of wood upright with an insulator in between, so that, because at higher voltages wood actually is not an insulator, even though you think it is. I don't want any kind of voltage bleed from the collectors into the base before it gets to the jars. So that's pretty much a plan of that. I just gotta get an upright for that and get another wheel, and we'll be able to finish most of the hard stuff actually, and then it's kind of just an assembly. But the way it works is one wheel is going to rotate one way and one's going to be the other, so it'll be pretty much somewhere in the neighborhood of that right there. This looks pretty cool on camera. I like that. So I'll pick those up in my travels sometime this week, and hopefully we can get this finished up by next week. At least I'm hoping. So I'll see you on the next video. Hope you guys enjoyed this one.